Right. So this is going to be the solution discussion for the mock 16 DILR section. This mock, I would say, is on an average, scoreable mock. You should be able to score at least 2 full sets. That is 8 questions. In fact, set number 3 and 4 have been quite easy in this. A good above average student should have attempted at least 10 to 11 questions, 10 to 12 questions, and got probably one wrong at best. Let's go ahead and see why am I saying this. Starting with the first set. This first set is actually based on a very nice. I don't know if it's called as a theorem, but a result which I'm going to discuss right now. This result basically uses this. I'm going to use an example to explain the result. So if you have an equation of the form ax plus by, where a and b are coprimes. A and B are coprimes, and x and y, these are non-negative integers. Then in such a case, depending upon different values of x and y, you can get different outputs for the final expression. Now if I ask you, what is the last number, what is the highest number that cannot be achieved using ax plus by? What is the highest number that cannot be achieved using ax plus by, and after that number every other possibility can exist for you. So that is given by the simple formula a into b minus a minus b. So this is the concept. If you understand this, the set becomes quite easy. Once again, so what does it mean? If I ask you 2x plus 5y, what is the largest number this 2x plus 5y cannot become? Given these conditions, 2 and 5 are coprimes anyway, and x and y are non-negative integers. So the answer is 2 into 5 minus 2 minus 5. So this is 10 minus 2 minus 5, which is 3. So 3 is the largest number 2x plus 5y cannot take. After 3, every number you can get. For example, how do you get 4? 4 you will get by 2 into 2. Your x is 2. Okay, and y is 0. How do you get, let's say 5? 5 you will get by putting x equal to 0, y equal to 1. How you will get 6? 6 you will get by putting x equal to 3, y equal to 0. So this way you can get every possibility, but the highest number you cannot get is 3. So this is the concept. Now the same concept will also be applied if I change the conditions into a and b are coprimes, but x and y, if I say the condition now is positive integers where zeros are not included, then the largest number is simply given by AB. The largest number is simply given by AB. So this minus A minus B won't come, right? So the proof of this is not really important, but this is an important concept you can remember. Now given this, let's understand how do we utilize this in this particular question. So the first question says Kallu is buying toffees and cost of each toffee is 7, and Billu is buying chocolates and the cost of each chocolate is 9. And there is some additional information given to us for question numbers 3 to 6. What does it say? Ramu is taking some chocolates and some toffees from Billu and Kallu, right? So that's and he gets at least one. Ramu gets at least one. So at least one toffee, one chocolate is taking from each one of them. The total number of toffees and chocolates that Ramu gets is at least one. All right. Okay, in fact this says the total number of toffees and chocolates that Ramu gets is at least 1. So basically you're saying that the total of toffee plus chocolate given to Ramu is at least 1. So it means it could be 1 toffee, 0 chocolates, it could be 0 toffee and 1 chocolate. Anyway, let's move on. If the total cost of all the toffees and chocolates bought by them is 631. So for the first question, 7 rupees into number of toffees is T plus 9 rupees into number of chocolates is C. This total is 631. How many distinct combinations of number of toffees and chocolates can they possibly have? So what I'll do is I will write T equal to 631 minus 9C by 7. Now this is an interesting concept. Please keep in mind, if you want to talk about what is the first value of T, you can go by hit and trial. Obviously you can randomly put values of T and C and see what you can get. You will get one value and from there you can form a chain. But otherwise the best way to do this is divide 631 by 7. If you divide 631 by 7, this is 90. So the remainder is 1, right? But you want this T to be an integer. If T has to be an integer, then this should be perfectly divisible. It means remainder 1 minus some other remainder should cancel out when you are dividing by 7. So this should be completely cancelled. So 9c by 7 should give you a remainder of 1. 9c by 7 should give you a remainder of 1. How do you get that? So now if you take 9 by 7, the remainder is 2. If you take 9 by 7, the remainder is 2. So what should you take as C so that your remainder turns out to be 1? Now you can see that 2 into, if you take C as 1, the remainder is 2. If you take 2 into the C as 2, the remainder is 4. 2 into 3, the remainder is 6. 2 into 4, the remainder is 8. But 8 means again it is 1. So you can take C as 4 and then test out the what happens. So 631 minus 9 4s are 36 by 7. Is this possible? So 631 minus 36, basically this is 5, 9, 595 by 7. 7 7s are 7 8s are 56. 35, 7 5s are 35, and you can see that you will be getting t as an integer. So this is a small trick you can keep in mind whenever you want to find integral values. Of course, there is always hit and trial available to you. So you got one set of values. So t and c, what are the set of values? Your c is, we just got, this is 4, in which case your t is 85. Now if you want to find other values, keep this small thing in mind. When there is a plus sign in between, your c changes. If you want to get the next c, increase it by the coefficient of t. If you are increasing c, then this will decrease by the coefficient of c, which is this is 7 and this will be 9. So 7 plus 4 will become 11, and 85 minus 9. 85 minus 9 is how much? 80, 76. And you can see that when t is 76 and c is 11, you'll still get the same answer. So just check it out. 76 into 7, 42, 7 7s are 49, 53. And for 9 11s are 99. So 1 1 3 1 631. So you can see it will work. If you want the next number, increase this by 7, that is the coefficient of t. So c should be increased by the coefficient of t and t should decrease by the coefficient of c. So 76 minus 9, which is 67, and this is how the series continues. Now the question is, how many distinct combinations are there? Now can you go backwards? You can't go backwards, because if you go backwards, this 4 should decrease by 7, but then c will become negative. So the series only keeps going forward. So how many distinct values can you have? Till where can you go? So you will basically see the series is 4 4 11. So 4 11, so this is 85 in that case. Let me quickly write it down. In fact, next is 11 plus 7. 11 plus 7 will become 18. Then 18 plus 7 will be 25, in which case 67 minus 9. 67 minus 9 will be 58. Then this is again by 7, 32. This is by 9, 49. This is by 7, 39. This is by 9, 40. This will again increase by 7. So 39, 46. So this will decrease by 9, 31. So this will keep decreasing. In fact, this will keep increasing on the positive side, no problem. This will keep continuing till this becomes negative. So instead of doing this manually, if you understood the concept, you're starting from 85 and next number it's like a progression, decreasing by 9. So this is 76. Next decreasing by 9. So this is 67. Till which number do you want? So 85, a plus n minus 1 into d. D is minus 9, where the last number should be greater than or equal to 0. How many terms can you get? So that's the question. So quickly, 85 minus 9n plus 9 greater than or equal to 0, or 85 plus 9. So 89, 94 greater than or equal to 9n, or n less than or equal to 10. N less than or equal to 10. So that's 10 point something. So that's 10. So you will get 10 terms. You will get totally 10 terms. The next question says, if the cost of all the toffees is 159, so all toffees is 70, is 159 more than the cost of all the chocolates, 9c, and the number of toffees are less than 1000, then how many combinations of toffees and chocolates are possible? Once again, you are forming a special equation. T is 159 plus 9c by 7. Now take 159, divide by 7, see the remainder. The remainder is 7 2s are 14, 19, 7 2s are 14. So the remainder will be 14, 5. Yeah, so the remainder is 5. Now remainder is 5 plus something else divided by 7 should leave no remainder, which means this remainder here should be 2. So 9c by 7, the remainder should be 2. How do you get 2? Already 9 by 7, the remainder is 2, which means c should be 1. So start looking at the values c and t. If c is 1, what happens to your t? You will have 159 plus 9, so which is 168 by 7. 7 2s are 14, 7 4s are 28. So you'll get t as 24. Now the equation actually this time is slightly different. It is 70 minus 9c equal to 159. This is the equation. Earlier you had plus here, but this time it is minus. So when it is minus, the concept remains the same. Increase c by the coefficient of t. So this will become increasing by plus 7. So this will become plus 8. But now for t, instead of decreasing it by the coefficient of c, you will increase here also by the coefficient of c because of the negative sign. So negative is decrease of decrease. So negative of decrease is positive. That's one way of understanding. So this becomes 24 plus 9. So 24 plus 9 is 33. Next will be 8 plus 7, which is 15, and this will also increase by plus 9, which is 42, and so on. Now t starting point is 24. You can't go below 24 because this is 1. If you go below, this is going to become negative. So the starting point of t is 24. So 24, 33, and so on. So this is again an AP. So 24 plus n minus 1 into plus 9. This is less than 1000 this time. So n minus 1 into 9 less than 976. N minus 1 less than 976 by 9. So 9 ones are 9. 0, 9 8s are 72 point something. So n should be less than 109 point something when this one also goes. 101 point something, which means, and n is an integer, keep in mind, it's a number of terms. So you will be getting the answer as option A, 109. Right, so moving on to question number 3. What is the maximum value which is not possible for the total cost of all the toffees and chocolates with Ramu? So now who is Ramu? Ramu is that person who is getting the chocolates. So Ramu is getting so let's say the first two people have 7 toffees T and chocolates C, out of which Ramu is getting X number of toffees and chocolates is getting Y. So what is the total cost with Ramu now? This is, anyway, toffees are still 7 rupees, chocolates are still 9, so it is 7x plus 9y. But please keep in mind, x and y can be zeros, but both of them cannot be 0. At least one is, they will, at least one of them have to be 1. Both of them cannot be zeros, which means effectively you're talking about x and y being non-negative integers, right? X and y being non-negative integers. Now, now we already know the formula. Ax plus by, the largest value that this cannot get is given by AB minus A minus B. So we can first check A and B have to be co-primes. Clearly 7 and 9 are co-primes, these two are co-primes. X and Y are supposed to be non-negative integers. Yes, based on the question given to us, they are 0 or above. Both cannot be zeros, of course. So the largest number is given by the formula 7 into 9 minus 7 minus 9. So this is 63 minus 9, 10, 16. So 63 minus 16 is 47. 47, 57, 63. Correct. The correct answer is 47. Okay. So this becomes very, very easy if you understand the concept. The next question, how many positive integral values cannot be the total cost of all the toffees and chocolates with Ramu? So if you're looking at Ramu once again, 7x and 7x rather x and y toffees and chocolates. So this is 7 and this is 9, right? So what could be the cost? So firstly 0 1 1 0, right? Now remember, you can get everything after 47. So after 47 you will get everything. So I have to check the total till 47. So if 0 1 and 1 7, so this is total. So 7 0 0, 9 1s are 9. So this is 7. Okay. Next, so this is the total chocolates as 1. Next, I can have total chocolates as 2, which means 0 2, 2 0, 1 1. So the total cost here will be 18. The total cost here is 14. The total cost here is 9 plus 7, 9 10, 9 plus 1 10, 16. All these are less than 47. So I have to check for all of these possibilities. Once I start crossing 47, I don't have to worry because the theorem that we just saw told me that after 47 you don't have to check. Every other value after 47 is possible. Then I will be looking at the total sum as 3. So these two are total adding up to 1. The number of items is 1. These 3 are the total. So these are 2, sorry. These are 2. These are 3. The total is adding up to 1. The total is adding up to 2. Next, total should add up to 3. So 0, 3, 3, 0, 1, 2, 2, 1. So these are 4 in number, but the totals are adding up to 3. Next, total should add up to 4. 0, 4, 4, 0, 1, 3, 3, 1, 2, 2. So these are how many? 5 in number, and the totals are adding up to 4. Let me also quickly write down the the total actual values so that it might be useful in further questions too. So this is 27, this is 21, this is 18 plus 27, 25. So this is 14 plus 9, 19, 23. This is 9 fours are 36. This is 7 fours are 28. This is 9 threes are 27. 27 plus 7, 34. And this is 7 threes are 21. 21 plus 9, 30. And this is 18 plus 14. 9 twos are 18 plus, so 7 plus 9 into 2. So that is 9, 10, 16 twos are 32. Okay. Then again, I'm not done. I'm looking at totals of 5. Total quantity is 5. So 0, 5, 1, 4, 2, 3, 3, 2, 4, 1 and 5, 0. So what is 5 and 0 total? 9 5s are 45. 9 4s are 36. 36 plus 7, 43. 9 3s are 27. 27 plus 7, 44. 44 plus, okay, so this is the problem now. So 27 plus 14, so 7, 8, 9, 10, 11, oh, this is 41. Okay, 41 is not a problem. Then you have 21 plus 18. So 21 plus 18 is 39. And then you have 7 4s are 28, 28 plus 9, 37. And then 7 5s are 35. So all of them are possible. So starting from 47, what are the totals? Totals are 1, 2, 3 up to 47. So 47 numbers are there. Out of this 47 numbers, I'm counting how many of them I'm able to achieve. The remaining I cannot get. So clearly I got number 9. If I'm looking at ascending order, number 9. In fact, number 7, then 9. Then I got number 14, 16, 18. So like this, I'm just making sure that there are no double counting. Is there any number which is counted double? I don't think so. So as of now, how many we got? So this is so 2 numbers here, 3 here. Then we had 4 here. 1, 2, 3, 4, 5. Then we had 5 here, and now 1, 2, 3, 4, 5, 6 here. So as of now, we got 6, 10, 15, 18, 20. So as of now, we got 20 of the 47. What more? I will just still go ahead, X, Y, and my total. Now, my total should add up to 6 now. So 0, 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, 6, 0. So quickly, 9 6 are 54, not possible, should not be counted. 9 5s are 45 plus 7, it's crossing 47, I should not count this. Because 47, 54 is definitely possible, so I don't need to worry about them. It's possible for me. I'm only looking at up to 47. Then 9 4s are 36. 36 plus 14. 36 plus 14 is 50. Again, not supposed to be counted. Then this is how much? 9 3s are 27, and 7 3s are 21. So 48, not supposed to be counted. The next one is 9 2s are 18, 7 4s are 28. So 16, 46. This is 46. Should be counted. Next one, 7 5s are 35. 35 plus 9. This is possible. This is how much? 44. This is counted. And then we have 7 6 are 42. Then let me continue this. So totally how many we got? Only we got 3. 3 here. So 20 plus 3. 23 out of 47 till now. Next, I will be looking at the total as 7, which means 0 7, 1 6, 2 5, 3 4, 4 3, 5 2, 6 1, 7 0. Now clearly this is not going to be counted because 7 9s is very high. 9 6s are again very high. 9 5s are 45 plus not possible. 9 4s are 36. 9 4s are 36 plus 7 3s are 21. This is already crossing 50. 9 3s are 27 plus 7 4s are 28. This is 40. This is also crossing 50. Then 7 5s are 35 plus 9 2s are 18. Not possible. 6 7s are 42. 6 7s are 42 plus 9. This is also crossing 50. and last one 7 sevens are 49. So you can see that none of them are counted. So after this you will not need anything else. After this, which means, see, when the total number of items are 7, you notice that none of them are useful for us. So then you don't have to worry about the totals of 8, 9s, 10s and all. So till now, if you notice, totally 23 numbers you got. Out of 47, 23 you got, which means the remaining 24. So 47 minus 23 is 24. These 24 you cannot get because you have looked at all the possibilities, and you got only 23 of them. So the remaining 24 out of the 47 you cannot get, and that is your answer, right? If it is known that Ramu gets at least one toffee and one chocolate, what is the maximum value which is not possible for the total cost of toffees with Ramu? So Ramu has 7x plus 9y. But now the condition for x and y are positive integers, if you notice, because he is getting at least one toffee and one chocolate. Now straight away the formula is a into b. The highest number that it cannot get is a into b. So 7 9s are 63. Straightforward. So if you know the concept, this question, at least 2-3 questions can be done within seconds. The last part, if it is known that Ramu gets at least one toffee and one chocolate, how many positive integer values cannot be the total cost of all the toffees and chocolates with Ramu? Now the same thing that we have done till now. So if you notice what we did till here in the previous question, we have seen up to 47, 23 of them we got, the remaining 24 we cannot get, and we have done till 7, right? But now we are looking at the total being 63. The total being 63. So we have to now start looking at counting till 63. So I will start changing these values a little bit here so that I don't have to rewrite everything. So now my limit is 63. Now let me see how many of them will now be calculated, will be possible for me. Yeah, so 54 is counted. Now 9 5s are 45, 45 plus 7 counted. This will be counted. 9 4s are 36, 36 plus 14, 50 counted. 9 3s are 27, 27 plus 21, this is counted. Then 46 counted, these 3 are anyway counted. So all of these, how many are them? 1, 2, 3, 4, 5, 6, 7. These 7 are also counted. Then if you come to this part, 7 9s are 63. This is 63, but this cannot be counted. Why? Because 0 is not allowed. Minimum is 1. By the way, that also, okay, so that is a problem. They have to keep few things in mind. Yes, so what are the things? 0 whenever it is, this is 0 and 1, so this is not counted. So only one of them is counted. 0 and 2, so 18 you cannot get, only 2. 0 and 3, 4 you cannot get, and 3 and 0 also, so 2 of them. Okay, so you'll have to change the values a little bit. You have to be careful. Zeros or any number with 0 in it, you cannot have it. So yeah, so this is 0. Both of them are gone. This is gone, only 1. This is gone, so this is 2. 2 of them are gone, so 5 minus 2 is 3. Then again 2 values are gone, so 6 minus 2 I'll be getting 4 here. So I'll just take a note of the things. So what are the things that I got? 0 plus 1 plus 2 plus 3 plus 4 plus. Now this is not calculated, this is not calculated, so the remaining 1 2 3 4 5. So this is 5 values, not 7, plus 5. And the next one again 63 is not counted, this is not counted. And let's take a look at this. So 1 and 6. So when 9 6 9s are 54 plus 7. 54 plus 7 is 61. So this is counted, and the remaining will be counted. All the others will be counted. So how many are them? 1 2 3 4 5 6, up to 6. So these are 6 values. So plus 6. But this is not the end of it. We'll have to go to the next step also. So let me create some space, erase the unnecessary things, and continue with my space creation as usual. So I will now look at, so I have seen total still 7. So I have to continue my journey post 7. So total should be 8 now. So I'll just write the totals as 8 and see how many of them are possible. So very quickly, let me just erase this. It's a bit lengthy, yeah, this part. So probably you can leave out 1 or 2 questions, out of 6. Do the remaining, move out. That's typically how you solve these kind of questions. Not everything needs to be attempted just because you know the concept. Yeah, almost done. This part, yes. Right. So now I'm looking at the total number of items as 8. So if total number of items are 8, 0, 8 is not possible. So 1, 7, 2, 6, 3, 5, 4, 4, 5, 3, 6, 2, 7, 1. How many of them will be counted? So 9, 7. 7 9 is 63. It's crossing 63. I should not count. 9 6 are 54. 54 plus 14. 68. 68 I should not count. 9 5s are 45 plus 21. 66 not supposed to be counted. 4 and 4. So that is 9. 9 4s are 36. 7 4s are 28. 8 9 10 14 3 4 5 6. 64 should not be counted. 27. 7 5s are 35. 7 8 9 10 11 12 3 4 5 6. 62. Yes, this will be counted. Then I think the other two should also be counted, but yeah, I think they should be counted. So counted and counted. So you have only 3 to be counted. So plus 3 out of total as 8. Out of total 8, now I'll be looking at totals 9. Total 9, 0 9 is not possible. I'll be looking at 1 8, 2 7, 3 6, 4 5, 5 4, 6 3, 7 2 and 8 1. Clearly this will not be counted. This will not be counted. This 9 6 are 54. This will not be counted. 9 5s are 45 plus 7 4s are 28. So it's crossing 70, not possible. 9 4s are 36 plus 7 5s are 35, crossing 60, not possible. 9 3s are 27 plus 6 7s are 42, crossing, not possible. 9 2s are 18, 7 7s are 49. 9 40 50 59, it's crossing 63, not possible. The last one, 7 8s are 56 plus 9, 56 plus 9, 9 10 15 65, not possible. The moment you get all not possible, you'll stop there. So what is this total? 1 plus 2 3, 3 plus 3 6, 6 plus 4 10, 15, 18, 24. So 24 out of 63. 24 out of 63 you can get. So if you can get 24 out of 63, what you cannot get? So 63 minus 24, this is 9, 2, 3, 4, 39. So 39 values. So 63 is done. That is the other question. That is the previous question. Yeah, you're looking at this. Yeah, so this answer should be 39. Well, so that's the answer for the first set. The first set, if you know the concept, 3-4 questions can be done very, very quickly. The other 2 questions you might have to, you could have left it, but that's the way to approach this.